We're going to do question 1, and 1.1 we are asked to solve for x. So we're going to solve for x for 1.1.1. So we're having x squared minus 6x being equals to 0. So the first step is to factorize. So we're going to factor out the x, and then we have x minus 6 being equals to 0. And then x will be equals to 0, or x minus 6 will be equals to 0. And therefore x being equals to 6 from this side. So, and then we have x being equals to 0. So these are our solutions of x for this problem. 1.1.2, where we are going to solve for x correct to 2 decimal places. So whenever we are given this, we know we have to use a quadratic formula because we cannot factorize the problem. So we have x squared plus 10x plus 8 being equals to 0, right? And our quadratic formula is x being equals to minus b plus or minus the root of b squared minus 4ac divided by 2a, right? And our a value is equals to 1, our b value is equals to 10, our c value is equals to 8. So you're going to substitute these values in your quadratic formula, and then you have x being equals to minus into 10 plus or minus the root of b squared, which is 10 squared minus 4, our a value being 1 and our c value being 8, right? And then we're going to divide by 2 into 1, right? So the solutions of x that you're supposed to get is minus 0.88, or x being equals to minus 9.12. So these are your solutions of x. So now we're going to do 1.1.3, solve for x with an inequality sign. So we're having 1 minus x, close bracket, open bracket, x plus 2 less than 0, right? So the first step is we're going to find our critical values, which 1 minus x being equals to 0, or x plus 2 is equals to 0. So we're going to transpose x to the other side. We'll have x being equals to 1, or x being equals to minus 2. So these are our critical values. So the next step we're going to do, we're going to draw our number line and present our critical values. So the first critical value is minus 2, and another critical value is 1, right? So I'm just going to write critical value, right? So what you're going to do here is you're going to test values before your critical values and values after your critical values, right? So the main solution that we are mostly interested in is a negative solution of y, right? Because we are given an inequality that says find the values of x such that the values of y are less than 0, right? So we are mostly interested in y values being negative. So the first step we're going to do is we're going to test any value below your minus 2, which can be minus 3 in this case, or you can choose minus 4, it's fine. And values between minus 2 and 1, we can simply say minus 1, right? And then values greater than 1 can be 2, 3, 4, whatever value you choose. So I'm just going to choose 2. So you're going to test these values here. You're going to test this value and this value and this value into your equation. Remember, you have equation of 1 minus x plus 2, right? So you're going to put, for example, you're going to put x equals to minus 3, right? Substitute it here and substitute it here and find the sign. yes, you're gonna get the answer, but we're mostly interested in the sign of the answer. So I did the calculations for x being equals to minus 3 rather, sorry, which is this one here, and I found that the sign of the solution being negative, so meaning that values that are less than minus 2 are going to give you negative solutions of y. And then I did test for x being equals to minus 1, right, and found that the y values of that solution are positive. So that's another solution. And also I tested for x being equals to 2 and found the solutions to be negative, right? So we are mostly interested in negative solutions, remember, because our inequality sign is less than 0. So as you can see, this is where you get negative solutions of y. So in this case, the first solution is less than our minus 2, and then the second solution is greater than 1, right? So we're going to use our critical values to conclude our solutions of x. So how do you do that? We're going to say, because we are mostly interested in the negative solutions of y, which is this one here and this one here. So we're going to use this inequality for the first solution and say x must be less than minus 2, right, to get this negative solution of y, right, or x must be greater than 1, right, to get this negative solution of y, right? So this are your solutions of x. We're going to do 1.1.4, where we're going to solve this sad form of equation. So we're having x plus 18 inside the square root being equals to x minus 2, right? So the first step we're going to do is square both sides, right? And what we're going to have on the left hand side is x plus 18 being equals to, so you're just going to expand this expression here, so it's going to be x minus 2 and x minus 2, and use FOIL method to find the product, right? So this to multiply this and that, so you're gonna have x plus 18 being equals to x times x is x squared, x multiplied by minus 2, minus 2x, x multiplied by minus 2, so it's minus 2x, plus 4, right? So you're going to have x plus 18 being equals to x squared minus 4x plus 4. So you're going to transpose this to the other side. We'll have x squared minus 4x plus 4 minus x minus 18 being equals to a 0, right? So you're going to have x squared minus 5x minus 14 being equals to 0. And then you're going to factorize, so you have x and x, 7 and 2, which are factors of 14 that give you the middle term. So here is going to be negative and here it will be positive, being equals to 0. So x is equals to minus 2, or x is equals to 7. So please test in the initial given problem and see which one is true, which solution of x is true. I did test and I found that x is not equals to minus 2. So this is the solution of x. Okay, so now we're going to do 1.2, where we are asked to solve simultaneously for x and y using both equations that are given below. So we're having x plus y being equals to 3, so this would be our equation 1, and we have 2x squared plus 4xy minus y equals to 15, so this would be our equation 2. So then we want to choose one equation to be our equation 3. So let's choose this one because it's simpler, and we can simply say x being equals to 3 minus y. So this would be our equation 3. So whenever we see x, we're going to substitute with 3 minus y, right? So what we have here is 2 into, so we're having x squared, right? So what we're going to do is we're going to say 3 minus y whole squared plus 4 into, so instead of writing x, we write 3 minus y multiplied by y minus y being equals to 15. So we're just going to expand this expression here. So you will have 2 into 3 minus y and 3 minus y plus 4 into 3 minus y multiplied by y minus y equals to 15. Then we're just gonna multiply through this expression here using your FOIL method. So we will have 2 into 3 multiplied by 3 will give you 9, and then we have minus 3y, which is this 3 multiplied by this 3, and then this 3 minus y multiplied by this 3 here is going to give you minus 3y also, plus y squared, and then plus this y here will multiply everything that it finds inside the bracket. So it's just going to be 4 into 3y minus y squared, close bracket, minus y is equals to 15. Right, so you'll have 2 into 9 minus 6y plus y squared plus, and then the 4 will multiply everything inside here, so it's going to be plus 12y minus 4y squared minus y equals to 15. Then the 2 will multiply everything inside the bracket, and we will have 18 minus 12y plus 2y squared plus 12y minus 4y squared minus y, and then let's take this 15 to the other side, so it's minus 15 equals to 0. And then if you call it like terms, you'll see that this minus y will subtract this 12y. So these two go away, and we'll remain with 18 plus 2y squared minus 4y squared minus y minus 15 being equals to 0. And then we subtract these two here, and we remain with minus 2y squared, and then this 18 and this minus 15 will give us plus 3, right? And then we're just going to say minus y being equals to 0, which is this y here, and then we write everything in standard form, so it's minus 2y squared minus y plus 3 being equals to 0. And then we're just going to divide by minus 1 both sides. We'll have 2y squared plus y minus 3 being equals to 0. So to factorize this expression here, which is equals to 0, it's going to be 2y, and here it's y, and we want to put 3 here and 1 here, so that when we add this 3y and this 2y, they give us the middle term, right? So so it's going to be a positive here and a negative here. So it's going to be 2y plus 3 being equals to 0, or y minus 1 being equals to 0. So we're going to transpose this 3 to the other side. We have 2y being equals to minus 3, or y being equals to 1. So we're going to divide by 2 here. So we have y being equals to minus 3 over 2, or y being equals to 1, right? So we're having our solutions of y. Now we need to identify the solutions of x. Remember that x is our third equation, which is equals to 3 minus y, right? So we're just going to substitute our values of y. So when y is equals to minus 3 over 2, what is our value of x? X being equals to 3 minus 3 over 2, right? So we're going to get a solution of 9 over 2. And when y is equals to 1, what is our value of x? It's equals to 3 minus into 1, and we'll get 2, right? So these are your solutions of x and y. Now we're going to do 1.3, and we are told that if n is the largest integer for which n to the power of 200 is less than 5 to the power of 300. So we need to determine the value of n. So what we have here is n being to the power of 200 less than 5 to the power of 300. So for us to find the value of n, we can use our laws of exponent and remove these 200. So we're going to multiply it by 1 over 200 both sides, so it's just going to be 1 over 200, right? And then we'll remain with n being less than 5 to the power of 300 divided by 200, right? So it's going to be n being less than, so this zeros go away, we have 5 to the power of 3 over 2, right? And you can put this in your calculator and you will have n being less than 11.18, right? So we can conclude and say n is actually equals to 11. So now we're going to do question 2. 2.1 says that we are given a sequence of 7x, y minus 11, which is said to be an arithmetic sequence. So we are asked to determine the value of x and y. We're having 7 x, y, and minus 11, and we are told that this is an arithmetic sequence. We are asked to identify the value of x and y, right? So for us to do that, we must use the constant difference to really get to find the values of x and y. So the constant difference says that, so before I write, let me just label my terms. This is term number 1, term number 2, term number 3, and term number 4. So the constant difference is that we're going to subtract term number 2 to term number 1 being equals to term number 3 minus term number 2, which is equals to term number 4 minus term number 3, right? So term number 2 is x minus 7, and then it's going to be y minus x being equals to minus 11 minus y, right? So you're just going to equate our equations of the constant difference, right? So we will have x minus 7 is equals to y minus x, and then if we transpose the x to the other side, we have 2x equals to, and transpose the minus 7, we have 7 plus y, right? And I equate this to equation 1, and then we will use this portion here and say y minus x is equals to minus 11 minus 1, right? And then I transpose the y to the other side, I have minus x being equals to minus 11 minus y, which is minus x being equals to minus 11 minus 2y. Then I divide by negative 1, I have x being equals to 11 plus 2y. So this would be my equation 2. So I'm going to substitute equation 2. So I'm going to substitute equation 2 into equation 1. So whenever I see x, I'm going to put 11 plus 2y. So it's going to be 2 into 11 plus 2y is equal to 7 plus y, and then I multiply the 2 inside the bracket. I have 22 plus 4y is equal to 7 plus y. Transpose the y to the other side and the 22 to the other side. I have 4y minus y is equal to minus 22 plus 7. And so it's going to be 3y is equal to minus 15. Divide by 3 both sides. I have y being equal to minus 5. So this is the solution of y, which is minus 5. To find the value of x, you will say x is equal to 11 plus 2. So I'm using this equation into minus 5, which is your y. So x is equal to 11 minus 10, and x is equal to 1. So this is the value of x. We're going to do 2.2, which says that given the quadratic number pattern of minus 3, 6, 27, and 60, 2.2.1 says that determine the general term of the pattern in the form of Tn is equals to an squared plus bn plus c. So we are asked to find the general term of this quadratic number pattern. So we're having minus 3, 6, 27, and 60, right? And so the first thing you're going to do is find the difference of this. So this is the first difference, so it's going to be 9, 21, and 33. So this is the first difference. And then we find the second difference, which will give you 12. So this is the second difference. So 2a is equals to the second difference, which is 12. So divide by 2 both sides. Your a value is equals to 6. So it's just going to be 6, right? And then 3a so your a value is equals to 6, and then 3a plus b is equals to the first term of the first difference, right? So which is equals to 9. This is the first term of the first difference, but we know that our a value is equals to 6, so it's going to be 3 into 6 plus b, which is equals to 9. And then we transpose this to the other side. We have b is equals to 9 minus 3 times 6, right? So our b value is going to be minus 9. And our a value, so it's a plus b plus c is equals to the first term of the sequence. So the first term is minus 3, right? So I'm just going to write minus 3 here. But we know that our a value is equals to 6, our b value is equals to minus 9. So to find c, we're just going to substitute. So it's going to be 6 minus 9 plus c is equals to minus 3, right? So you should get your c value being equals to 0. Then the general term of this, therefore the general term of the sequence, which is written as therefore the general term of the sequence is equal to Tn being equals to an squared plus bn plus c. And to substitute the values that we found, a value is equal to 6, so it's going to be 6n squared, and b is minus 9, so it's minus 9n, and c is 0. So this would be your general term of the sequence. So 2.2.2 says that calculate the value of the 50th term of the pattern. So we have our Tn being equals to 6n squared minus 9n, right? and we are asked to find t of 50, which is 6 into 50 squared minus 9 into 50. So the answer that you're supposed to get if you punch your calculator, it's 14550, 14,550. 2.2.3, show that the sum of the first n first differences of this pattern can be written as Sn being equals to 6n squared plus 3n. So we must just write the sum of the n first differences of the pattern, right? And show that it's going to give us this value. So what this means is we need to remember that the first difference of the sequence, which was found to be 21, the first difference of the sequence is 9, 21, and 33, right? And you need to note that the first difference of a quadratic number pattern is actually an arithmetic sequence, right? So we need to identify the sum of this arithmetic sequence, where the difference between these two terms is just going to give you 12, right? So it means now that d is equals to 12, our a value is equals to 9. So we can find the sum. The sum is equals to n over 2 into 2a plus into n minus 1 multiplied by d, right? So we're just going to substitute. So it's going to be n over 2 into 2, our a value is 9, plus into n minus 1, our d value is 12, right? So it's going to be n over 2 into 2 times 9 is equals to 18, and then 12 times this n here, so it's going to be plus 12n, and then 12 times this minus 1 is going to be minus 12. We close the bracket, and then we're going to have n over 2 into this 12n here, so it's going to be 12n, and then we say 18 minus 12, we're going to get 6, and then we're going to multiply this n over 2 inside the brackets, and the final answer that you need to get, okay, before I say the final answer, it's going to be n over 2 times 12n plus n over 2 times 6, right? So this 2 will divide from 12, then you get 6, and then n times n, it's n squared, and then this 2 will divide, and 6 you get 3, so it's going to be plus 3n. So this is the sum of n terms, so it's definitely equals to the one that we are given. Now we're going to do 2.2.4, which says that how many consecutive first differences were added to the first term? How many consecutive first differences? Remember, the first differences we found in the previous question, it was Sn, right? So here we're just gonna write Sn. How many Sn were added to the first term? So first term, it's T1 of the quadratic number pattern to obtain a term in the quadratic number pattern of the value of 21,060. So what this means is the following. So it means now that how many sum were added to the first term of the quadratic number pattern, giving us 21060, right? And we found the sum in the previous question to be 6n squared plus 3n, right? And the first term of the quadratic number pattern is minus 3, right? It's minus 3 being equals to 21060. So this minus 3, you can just check it. It's this one here of our quadratic number pattern, right? So what you're going to do is just add and subtract everything. So we're going to transpose this to the other side. So you have 6n squared plus 3n minus 3 minus 21060 being equals to 0, right? So the whole point here is to identify the n, term, right? So it's going to be 6n squared plus 3n minus 21063 being equals to 0. And then we can use the quadratic formula, which is x being equals to minus b plus or minus root of b squared minus 4ac divided by 2a, right? Where our a value is equals to 6, our d value is equals to 3, our c value is equals to minus 21063, right? Let me write this 3 properly. 6, 3, right? So we'll substitute into the equation. So it's going to be x being equals to minus, our b value is 3. Sorry, this is supposed to be b is equals to 3. So our b is 3, and then plus or minus the root of 3 squared minus 4, our a value is 6, and our c value is minus 21063, close brackets. Then we divide by 2 into our a is 6. So the x value that we're supposed to get is 59, or x equals to minus 59.5, right? Remember that it's not necessarily x, but it's n. N is equals to 59, or n is equals to minus 59.5, of which the number of terms can never be minus 59.5. A negative can never be a negative, so we'll take this answer here, which is n being equals to 59. Okay, so question 3, 3.1, we are asked to prove that this sum here that is given, this one here, is a convergence geometric series. So we must show all calculations for that. So for us to prove that this sum is a convergence, we need to first identify the 3 terms of the sequence, right? So when k is equals to 1, we're going to substitute that into the value of k of 1, and we find 12 if you punch your calculator. When k is equals to 2, say 4 multiplied by 3 to the power of 2 minus 2 equals to 4. And when k is equals to 3, we have 4 multiplied by 3 to the power of 2 minus, sorry about that, so it's 2 minus into 3, and then we get a value of 4 over 3, right? So we're having our terms. The first term is 12, the second term is 4, the third term is 4 over 3. So now, for us to prove that, to prove convergence, we need to first find the ratio of these terms. So this is term number 1, term number 2, term number 3, right? So the ratio is equal to term number 2 over term number 1 is equal to term number 3 over term number 2, right? And we find 4 over 12 is equals to 4 over 3 divided by 4. So the ratio that we found here is 1 over 3, right? So and to prove convergence, we know that r must lie between minus 1 and 1, and since we found r to be 1 over 3, it definitely lies between minus 1 and 1. So therefore the series here converges, right? So we've answered the question. So now we're going to do 3.2, where we are told that if the sum, this sum here, which if you take a look is the same as this one here, the previous one, just that it starts at k is equals to p, right? So if the sum is equals to 2 over 9, we must identify the value of p, right? So for us to identify the value of p, so we're having the sum to infinity when k is equals to p, multiplied by 4, 3, 2 minus k, it's equals to 2 over 9. So we know that the sum to infinity is equals to 2 over 9. That's the first thing that we know. And we are given that k is equals to p, right? So we are asked to find p. So we are asked to find the value of p, right? So for us to find the value of p, we already know the number of terms. The previous terms that we found was 12, 4, and 4 over 3, right? But because here it says k is equals to p, so you're going to first find that k is equals to p and substitute where there's k. 4 multiplied by 3 to the power of 2 minus p. So this is going to be our first term. So it's going to be 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p. Right? So this is going to be t1, our first term, our value of a, right? T1 is the same as equals to a, right? So yeah, what we're going to do is this. So we're going to write our sum to infinity, which is equals to a over 1 minus r, where our sum to infinity is 2 over 9, right? And our value of a is going to be what we found, this part here, right? Which is 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p divided by 1 minus our r from previous question was 1 over 3, right? So we're going to cross multiply this expression here, right? So but before we do that, let's first deal with what's at the bottom here, right? So what we're going to have is we will have 2 over 9 is equals to 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p divided by, so 1 minus 1 over 3 will give you 2 over 3. Then we cross multiply. You're going to have 2 over 9 multiplied by 2 over 3 being equals to 4 multiplied by 3 to the power of 2 multiplied by 3 to the power of minus p, right? So what you're going to do is we're just going to, if you multiply these two here, right? So, and you also multiply these two here, you're going to have 4 over 27 is equals to 36 multiplied by 3 to the power of minus p, right? And then we divide by this 36. So divide by 36, divide by 36. So you're going to have 1 over 243 is equals to 3 to the power of minus p, right? So 243 is the same as 3 to the power of 5, right? So we're just going to write that down. So it's going to be 1 over 3 to the power of 5 is equals to 3 to the power of minus p. And then you take this up, we will have 3 to the power of minus 5 is equals to 3 to the power of minus p. So if same base, we're just going to drop the exponent. So minus 5 is equals to minus p. Divide by negative 1 both sides, we have p being equals to 5. So our p value is equals to 5. So now we're going to do question 4. In 4.1, we are given this function here of h of x being equals to minus 3 over x minus 1 plus 2, right? So in 4.1.1, we are asked to write down the equations of the asymptotes of h, right? So having h of x being equals to minus 3 over x minus 1 plus 2. So the equations of asymptotes, we have the vertical asymptote being equals to 1 and the horizontal asymptote being equals to 2. So these are your asymptotes. And then now 4.1.2 says that determine the equation of the axis of symmetry of h that has a negative gradient. So for us to identify the equation of symmetry, we have our h of x being equals to minus 3 over x minus 1 plus 2, right? And the axis of symmetry that are negative, m must be equals to negative 1, right? So our equation will be mx plus c, where our m is equals to negative 1, so it's going to be y is equals to minus x plus c. So y is the negative asymptote, the negative axis of symmetry rather, negative 1. Let's say for an example, excuse me, let's say for an example you have your Cartesian plane like this, and you have your graph, your hyperbola, and this is your hyperbola. So your axis of symmetry passes through here. So this, because it's going down, it's going to be your negative axis of symmetry because it's dividing the graph into two equal parts. So the gradient for this would be equals to -1. But there's also another axis of symmetry that passes through in this form, which is increasing. So the gradient for this one will be equals to 1. So the gradients are always these values here, right? So the increasing axis of symmetry is equals to 1, +1. The decreasing axis of symmetry is -1, right? So hence here we chose -1 because we are asked to find the negative gradient, the one with the negative gradient, right? Axis of symmetry. So, and another thing that you need to note is this point here, right? So when you identify your equation of axis of symmetry, you're going to use a point which is where your vertical and horizontal asymptotes intersect. You see, this is the point where your asymptotes intersect. Why am I saying that? Looking at this graph here, let's say it's f of x, right? The asymptotes are traveling here at the axes, right? And another one is traveling here, right? So hence here we would say it's 0 and 0, right? So meaning that if you were to find the equation, you were to use the point of 0 and 0. So now going to our question that we are given. So we now know that the gradient, because we're talking of a negative axis of symmetry, the gradient is supposed to be -1, right? So we just indicated that it's -1, fine. So now we need to use the points, 2 points. So we have our asymptotes. Our vertical asymptotes equals to 1. Our horizontal asymptotes is equals to 2. Right? So we're going to use that as a point to find this value of c here. So we're going to use this 1 and this 2 as a point. So we're going to substitute, this is x, this is y, substitute in this equation here. So where there's y, you're going to put 2 is equals to minus, where there's x, you put 1 plus c. So it's going to be 2 is equals to -1 plus c, and then transpose the -1 to the other side. We have c being equals to 3, right? So now you have c is equals to 3. Your equation is y is equals to mx plus c, where your m is equals to -1 because it's a negative axis of symmetry. Your c is equals to 3, so you're just going to substitute that. It's going to be -x plus 3, right? So it's just going to be plus 3 here. So this is your equation of your axis of symmetry, the negative gradient axis of symmetry. So now 4.1.3, you are asked to sketch the graph of H showing all asymptotes and intercepts of the axes. So what we're going to do is, we know our vertical asymptotes, x of v is equals to 1, and y of horizontal asymptotes equals to 2. And another thing that's important is for us to find the y-intercept when x equals to 0, x-intercept when y is equals to 0, right? So we know that our h of x is given as -3 over, so this is 3, let me write it nicely. So it's -3 over x minus 1 plus 2, right? So let's find the x-intercepts when y is equals to 0. So it's going to be 0 is equals to -3 over x minus 1 plus 2. Transpose the 2 to the other side. We have -2 is equals to -3 over x minus 1, right? And we cross multiply, -2 into x minus 1 equals to -3. Divide by -2 both sides. We have x minus 1 is equals to 3 over 2. Transpose the 1 to the other side. We have x equals to 3 over 2 plus 1, right? So we're going to have x equals to 5 over 2. So this is your x-intercept, 5 over 2 and 0. So now find your y-intercept when x equals to 0. So you have h of 0 is equals to -3 over 0 minus 1 plus 2. And you'll have -3 over -1 plus 2, which is equals to 3 plus 2 equals to 5. So your y-intercept is 0 and 5, right? So now you have your intercepts, which is let me indicate here. So your intercepts you have your intercept of 0 and 5, and 5 over 2 and 0, and then you have your asymptotes, which your vertical asymptote equals to 1, your horizontal asymptote is equals to 2. So now you can draw your hyperbola, right? So you're just going to draw. Remember that the equation is given as h of x is equals to minus 3 over x minus 1, so plus 2, right? So this a value of minus 3, so this is the a value, which is minus 3. It tells us which quadrant our hyperbola is going to be. So if these were the asymptotes, it's going to be in the second and fourth quadrants, right? So you need to expect our hyperbola to be in the second and fourth quadrant of our asymptotes. So what we're going to do is we're going to indicate our asymptotes in the graph. So we're having our vertical asymptote being equals to 1. So let's say this is our vertical asymptote, x equals to 1. Our horizontal asymptote being equals to 2. So this would be our y equals to 2, right? And then we're having our y-intercept here being 0 and 5. So let's say 0 and 5 is somewhere here. And so this is the asymptote going up. And then let me remove this. So, and then, so this is, oh, excuse me. So, now we have our y-intercept here, which is 0 and 5. So as y-intercept is 5, and this is our asymptotes, right? The blue line going up, it's our vertical asymptotes. And then now we're going to write down another intercept, which is this one here, 5 over 2, which would be somewhere here, right? So now these 2 points, as I indicated, they are telling us where our graph should be. So meaning our graph will look something like this and like that. So they won't, the graph won't touch the asymptotes, right? The blue lines that you can see here. So this is the graph of this problem here, where you need to indicate your axes, right? So this would be your y and this would be your x. Now in 4.2, we are given the graph of f. This is the equation of the graph of f, right? And the graph of g. And we are told that a is the turning point of f. So if we look at this, the graph of f, right? And a is the turning point of f, right? And we are also told that the axis of symmetry of f intersects the x-axis at E, right? And then the line G at DM, right? So there is DM there, and this is your axis of symmetry, right? Of f, right? Because it comes down from your turning point. And then what do we have? C is the y-intercept of f and g, which is this point here. Cool. So there is your graph, and let's answer the questions that follow. So having 4.2.1, write down the coordinates of A. So we need to write down the coordinates of this turning point here. So we're having our equation. This is the equation that we're given. Basically the coordinates is just these values here, right? So we're having 5 and 8 here. So our f of x, so to find the coordinates of A, because we're writing them down, it's going to be minus 5, because here we have x plus 5. X plus 5 equals to 0, so you transpose the 5 to the other side with x being equals to minus 5. So it's going to be minus 5 and minus 8. So these are your turning point of this graph of f. So hence the turning point are actually the A value. So now we're done answering this question here. And then 4.2.2, write down the range of f. So we are having this function here, and we just identified the coordinate of a, right, to be minus 5 and 8. So we have minus 5 and is it positive 8? No, it's negative 8 minus 8, right? And to find the range, so the range is talking about the y values. So when you talk of the range, we want to interpret the y values, the movement of y values, right? If this is the y-axis and this is the x-axis, to interpret the movement of y values use of this graph of f, right? We know very well that the y values come from a positive infinity, goes down to this minimum point here of minus 8. Remember, we are looking for the y values, and then it goes up to another positive infinity. So there's two ways to write down the range of this function here. You can simply say y is greater or equals to minus 8. Why are we saying equals to? Greater or equals to? Because the equal sign means now that the minus 8 is part of the graph, so hence we're putting the equal sign, right? Or someone can just write from positive infinity to 8, right? This would be solid, this would be like that. So positive infinity, and so this is minus 8, by the way, minus 8 to positive infinity. So someone else can write it like this, it will still be correct. We know that here it's minus 5 and minus 8, right? So to find the values of d, which is m and n, right? And this m here is actually this same x. M is actually equals to minus 5. Why am I saying that? Is because this is the axis of symmetry of the parabola, right? So whatever x value is here, it's the same as the x value that is there. So we are done finding this m being equals to minus 5. So now we need to find this n, right? So to find this n, you can simply use, because the d point touches the straight line. So this is a straight line, right? It touches the straight line, so meaning you can use the equation of the straight line to find the value of n, right? So the equation of the straight line is this one here. G of x is equals to half x plus 9 over 2. So you can simply use that one. G of x is equals to half x plus 9 over 2, right? So the m value here, this m value is actually the x value. So you can simply substitute it. Minus 5 equals to 1 over 2 into minus 5 plus 9 over 2, right? So you're just going to substitute that into the equation, and the answer that you're going to get is 2. So therefore our n value is equals to 2, right? So that is the value of m and n. So this is the value of m, this is the value of n. Then in 4.2.4 we are asked to find the area of OCDE. So for us to find this area, so we want the area of D, E, right? So we want to find the area of this shape here, which looks like, yeah, it is a trapezium, right? So the D we now know it's actually D being equals to our m value we found to be minus 5, and our n value is 2, right? So what this means is from this E to D, the height from E to D is actually 2. So from here to here is 2 units, and then here this point, it's going to be the y-intercept. So what's the y-intercept of the straight line or the parabola? It's 9 over 2, right? It's 9 over 2, so you can simply write 9 over 2 there, and this distance here from O to E, we know it's going to be 5, right? Yes, it's minus 5, but because we are writing it in units form, we're just going to say it's 5. So if I were to just write down this shape here, let me do this. So if I were to write down the shape of this trapezium, it's going to look something like this, right? Where this small part here and this large part and this distance here. So this is 5 units. Let me write it nicely. So this is 5 units, and this is 9 over 2 units, and this is 2 units, right? So let me just confirm. Yes, looking at the diagram, yes. So now you can just simply find the area of this, right? Because they said they wanted the area of OCDE. So this is O, this is C, this is D, this is E. To find the area of a trapezium is equals to half DE plus CO multiplied by perpendicular height of OE, right? So I'm just writing with respect to the shape. So it's going to be half our small side, which is 2 units, plus our large side, which is our large height rather, which is 9 over 2 multiplied by the base, which is, we normally say it's the perpendicular height, but yeah, this is just going to be saying it's a base of 5 units, right? So punch this in your calculator and you should get an area of 16.25 in decimal form, or you'll get 65 over 4. So, and then 4.2.5, you're asked to determine the equation of the inverse of G, right, in the form y is equals to. So if we go back to the given equations, we can see that this is the equation of G, and we are asked to find the inverse of this equation here, right? So what you're going to do is this. So we have our g of x being equals to 1 over 2x plus 9 over 2, right? And which is y is equals to 1 over 2x plus 9 over 2. So you're just going to swap. So it's going to be x equals to 1 over 2y plus 9 over 2, right? And we're going to transpose this to the other side. We have x minus 9 over 2 is equals to half y, and then we divide everything by half, right? So our y is going to be equals to 2x minus 9, right? So this would be your inverse of the function, which is 2x minus 9. So let me just write this 9 properly here. So it's going to be y is equals to 2x minus 9. So now 4.2.6, we are told that if h of x is equals to the inverse of g plus k, if this is a tangent rather to f, so if this whole thing here is a tangent to f, determine the coordinates of the point of contact between h and f, right? So the point of contact, remember that f is a parabola, right? So the point of contact between this, so let's say this is a parabola and it has a turning point here. Let me use another color. So this is the turning point of this parabola, and if we have this line, the tangent line, then which means it's going to pass like this, right? So the tangent is going to pass and it will touch at one point at the turning point of the parabola, right? So what we need here, we need to identify this point where these two, the graph of h of x and f of x intersects. We need to identify that point, the very same point. So how we're going to do that? We are given that h of x is equals to the inverse of g plus k, right? So, and we know that f of x is equals to, so is equals to 1 over 2 into x plus 5 squared minus 8, right? So if you were to simplify further by expanding this, by doing this, x plus 5 minus 8, if you were to find the product of this, you should get okay, let me just do that. So it's 1 over 2 into x squared plus 5x plus 5x plus 25 minus 8, which would be 1 over 2 into x squared plus 10x plus 25 minus 8. So this half will multiply everything that is inside, and then you collect the like terms, but the standard form of equation that you need to get is 1 over 2x squared plus 5x plus 9 over 2. So this would be your f of x in standard form. So what you have now is you're having f of x in standard form of 1 over 2x squared plus 5x plus 9 over 2, right? And you're having h of x, which is equal to the inverse of g plus k. So what is the inverse of g? The inverse of g is equals to 2x minus 9, right? So if f of x is equals to 1 over 2 x squared plus 5x plus 9 over 2, and h of x, if you substitute this and put it inside here, h of x would be equal to 2x minus 9 plus k, right? So this is what we are having here, f of x and h of x, right? So for us to find the point where these two meet, right, we need to derive this. So we can derive the f of x, and we'll have f prime of x being equals to 1 over 2 times 2x to the power of 2 minus 1 plus 5. So f prime x is equals to x plus 5, right? So this is the derivative of this one here. So and then for the h of x, right, we're just going to derive it. We'll have 2, right? So that's the derivative, because these are constants, right? So we are going to say f prime of x is actually equals to h prime of x, because they meet at that point, right? The gradients are equal. So instead of writing f prime x, we're going to write this x plus 5. So x plus 5 is equals to 2. So transpose the 5 to the other side, you have x equals to 2 minus 5, and then our x is equals to minus 3, right? So now that we know the x value of the point of contact between these two, we need to find the y value, right? So you can substitute the y value into the original equation. So it can be the original equation of f of x, where it was 1 over 2 into x plus 5 squared minus 8, right? So you can substitute your x value of minus 3. F of x equals to minus 3 equals to 1 over 2 into minus 3 plus 5 squared minus 8, right? So you will get a value of minus 6. So this is your other coordinate. So complete coordinate is going to be minus 3 and minus 6. Now we're going to do question 5. The graph of f of x is equals to 3 to the power of minus x is sketched below. A is the y-intercept of f, B is the point of intersection of f, and the line y is equals to 9. So this is what we're having here. our graph of f, where this is the line of y is equals to 9, right, passing through b at this point. And yes, this is our a value here, and that's basically that. So let's answer the question. So we have 5.1. Write down the coordinates of a. So what you can do here is you can write down the coordinates of a. If you can just do it by inspection, or you can just find it, right? So I'm just going to find it for you. So it's going to be f of x equals to 3 to the power of minus x, right? And what we know is that at this point a, x is equals to 0, but we don't know the value of y, right? So for us to find the value of y, you can simply say f of 0 is equals to 3 to the power of minus 0. So anything to the power of 0 is 1, so it's going to be equals to 1. So now we know that y is equals to 1. So you can simply write 1, right? So where there's y, you put 1. So that is the coordinate of a, which is 0 and 1. So now going to 5.2, they say write down the coordinates of b. So we're having b at this point here, and we know very well that we don't know the value of x, but we know the value of y to be 9, right? Because of this equation of y is equals to 9. So to find that, we have our f of x being equals to 3 to the power of minus x, right? Yes. So we're going to substitute this value of y to find the value of x, right? So y is equals to 9 being equals to 3 to the power of minus x, and 3 to the power of 2, sorry. 3 to the power of 2 is 9, right? Equals to 3 to the power of minus x. So same base, you drop the exponent, so minus x is equals to 2, and then you divide by minus 1, divide by minus 1. X is equals to minus 2, so that is the x value of b. So therefore our coordinates of b is minus 2 and 9. So that is the solution for this problem here. And then now I'm going to do another question. So okay, let me just remove this and say minus 2. Okay, so 5.3, write down the domain of f of minus x, right? So this one here is we first need to know the domain. What are we talking about? Looking at just f of x, right? The domain, the movement of x values, right? From that direction to that direction, right? Remember, this is x-axis, so you're looking at the movement of the x values. So how am I going to interpret that? We know very well that looking at this graph of f, the values of x come from a negative infinity to a positive infinity, because your graph is moving from that direction, going down like that, to that direction, right? So if you were asked the domain of this graph of f, you are going to say from negative infinity to positive infinity, right? X the element of that for your graph of f, by the way, for f of x. So but now we want the domain of f, the inverse of f, right? So for us to find that domain, we know very well that the inverse is going to be in if we were to draw the line of y is equals to x, it's going to move like this, right? Y is equals to x, where this part here will be, and this part here, so it's gonna look let me first do this. We have f of x being equals to 3 to the power of minus x, right? So we have y is equals to 3 to the power of minus x, right? So the inverse would be x being equals to 3 to the power of minus y is equals to log of base 3x, right? And then y is equals to minus log of base 3x, right? So for us to be able to identify the movement of this function here is, if you substitute 0 here, right, you won't get the solution of y. So what does this mean? It means that the graph doesn't touch the y-axis. It does not touch the y-axis. So the inverse does not touch the y-axis. But if you put even if you put a negative x value, you won't get the solution of y. In this equation, I'm talking about this equation, you won't get the solution of y. But if you substitute here any value that is greater than 0, you will definitely get the solution of y, right? So this tells you that all the x values are above 0, right? So that is your domain for this function here. So your domain for the inverse of f is x must be greater than 0, right? As I said, substitute in this equation, you'll see what I'm talking about. Substitute negative 1 on this x and see if you're going to get a solution. Substitute 0 and see if you're going to get a solution. And what solution you're getting? Your calculator will just give you errors. And substitute 1, substitute 2, substitute 3, just like that. You'll see that just above 0 you'll get solutions of y, right? But you won't get a solution of y at 0. You won't get a solution of y at negative 1. So this is the solution of this problem here. X must be greater than 0. To move to 5.4, we say that describe the translation from f to h of x being equals to 27 over 3 to the power of x. So when you talk about the translation, we are talking about the movement. It can move to the horizontal or vertical, right? We're talking about the shift. The shift. What type of shift is it moving? Excuse me, is it moving 2 units up, 3 units left, to the left, or to the right, or to downwards? You know, that is translation. So for us to be able to talk about the translation of h of x, let's first simplify this problem here, 3 to the power of x. So to get 27, you know, it's 3 to the power of 3. Let me write that 3 properly. 3 to the power of 3 over 3 to the power of x, right? And let me take this to upwards. We have 3 to the power of 3 multiplied by 3 to the power of negative x. So h of x, like that. And then now to write it as singular, you can see 3 to the power of 3 minus x, like that, right? So you can see that how we interpret the shift, this will help us tell about the shift, right? So the shift is, we have 3 minus x is equals to 0. So the top part, we are equating it to 0 to identify the shift. And transpose the 3 to the other side, you have minus x equals to minus 3. Divide by minus 1 both sides, so x is equals to 3. So this tells us that the graph shift 3 units, but because of the 3 being equal, being positive, it tells us that the shift is to the right, to the positive side of the x-axis, right? So therefore, by interpreting the shift, you can simply say shift 3 units to the right. So that is the shift of this problem here, or this graph of h of x rather. So now we're going to do 5.5. Determine the values of x for which h of x is less than 0. So what you can do is this. Remember the graph of h of x that we just found. We found h of x to be equals to 3 to the power of 3 minus x, right? This is what we found. So to really interpret this, it says h of x less than 1. So we want to find the values of x when that happens. So you can simply substitute here, substitute this same equation and say 3 to the power of 3 minus x less than 1. And we can use our logs, right? So this is the base 3, right? Or we can simply just say 3 to the power of 3 minus x less than, so the 1 we can change it to 3 to the power of 0, right? So it's 3 to the power of 0, and then same base, we just drop the exponents, so 3 minus x less than 0, and then we transpose the 3 to the other side, we have minus x less than minus 3, and then we divide by negative 1 both sides. X is greater than 3. Yes, the sign changes, the inequality sign changes if you divide with a negative. So we have x being greater than 3. So that is the solution. Okay, so now we're going to do question 6, and 6.1 says that on the 31st of January 2020, Tsepo made the first of his monthly deposits of 1,000 Rand into a savings account. He continues to make monthly deposits of 1,000 Rand at the end of each month up until the 31st of January 2032, right? So the interest rate was fixed to 7.5% per annum compounded monthly. 6.1.1, what will the investment be worth immediately after the first deposit? So we want to identify the future value here, right? Because Tsepo is making investments, right? So of 1,000 Rand. So we want to know in future, in 2032, how much will his amount in the account be, right? Hence we are told here that what will the investment be worth immediately? This is critical. Immediately after the last deposit. So the one thing that we have here is we have that the investment is equals to 1,000 Rand, right? And the interest rate is 7.5% per annum compounded monthly, right? Compounded monthly. And another thing is when you want to now determine your number of payments, the N. So you're gonna minus your 2032 minus 2020. Let me just punch that into my calculator. I'm going to get 12, right? Which basically means 12 years, right? So what is going to happen here is you're just going to have that 12 years and then you multiply it with the monthly, which is 12, right? So it's just going to be 144. But remember that the investment is going to be made immediately. So what they're saying is want to know how much will be in the investment if, you know, this point here written immediately is really critical. So you're just going to add 1 because it's immediately, right? Just going to write a timeline to really show you what this means. So you're having your timeline here, right? So this is T0 and this is 12, right, for 12 years. And what we know is that payment will be made on the 2020 or the 31st of 2020, right? That's the first payment. And then the last payment you made on the 31st of January, right? So hence I said you will have your T1 here all the way up to the 12th year, right? And what we will have here, so we know very well that there will be payments of 1,000 Rand each year, each month, sorry, payments of 1,000 Rand, just payments of 1,000 Rand. So we're mostly interested in the future value of this investment that is being made, right, of this person here. So what we will do is we'll use the future value annuity. So we're going to say fv is equals to x into 1 plus I to the power of n minus 1, right? So we know very well that investments of 1,000 are put into the account, and the interest rate is equals to let me just check here. The interest rate is 7.5% compounded monthly, right? So it's just going to be 1 plus 7.5%. You can write 0.075, right? Because 7.5% divided by 100 will give you 0.075. So it's 0.075, and it's compounded monthly, so it's 12 to the power of just going to write to the power of 145. Remember I said it's 12 years multiplied by the 12, which is compounded monthly, which will give you 144, because we want the future value when the last payment is made immediately. So just going to add 1, which would be 145, right? So we're just going to be 145 here, and then divided by 0.075 over 12. So you're just gonna punch everything in your calculator here, just everything that you see here, just punch it in your calculator so that we can find the future value annuity, which will be 234,888.85. So this is point. So this is the future value annuity of this investment that has been made here. Now we're gonna write 6.1.2, this one here. So if he makes no further payments but leaves the money into the account, how much money will be in the account in 2033? So if you make investments into an account, and then remember this is 2020, so the last investment was made in 2032. So if you leave your money and not take it, you will gain interest, right? So you'll gain interest. So because we are looking at the 31st of January 2033, right? And we know that the last last payment of the investment was made on the 21st of Jan 2032, right? So the difference here is 1 year. So there's 1 year of interest made, which you can change that 1 year into 12 months, right? So what is going to happen is this: we calculated the future value annuity, right, which was 234,888.85. So if you leave this amount into your account and just not take it, you're going to have an interest. So to really identify the interest that you're gonna make, not necessarily the interest, but the accumulated amount for leaving your money in your bank. So you're just gonna have A is equals to P. So you're gonna use a compound formula now, because it's just a small period. It's not really annuities here. We just want to identify the accumulated amount that you would have made if you just left it there in your bank. So you're not making any constant payments now, hence we're using this formula here to the power n. So we're just going to write 234,888.85 into 1 plus remember the interest rate 0.075 divided by 12 to the power of 12, right? So this is just your compounded monthly, and remember that it's multiplied by 1 for 1 year, right? So this 12 will just convert into months, so hence yeah, it's just we can write 12 if you want, or you can just write 12 multiplied by 1 because it's 1 year. It's 20 from 2032 to 2033, right? So punch this in your calculator and you're supposed to get an answer of 253,123.5398, right? So this is the answer, or you can just write in 1 decimal place or 2 decimal place. It's up to you, as long as that is towards the final answer. Don't round off during calculations. So yeah, this is the final answer for this problem here. So now looking at 6.2. So 6.2, Jimmy bought a new car for 250,000 rand. The value of the car depreciates at the rate of 22% per annum annually according to the reducing balance. So whenever we talk of reducing balance, we're talking of a compound formula, right? So always remember that reducing balance, compound formula. Let me write compound. And if we're talking of a straight line, we're talking of simple interest, right? Or simple interest formula. So don't forget that. This car depreciates, obviously. So after how many years will its book value be this amount here? So the book value, we're talking of A, which is the accumulated amount. So we just wanna, so we know the formula we're gonna use, but remember this is a depreciation, so hence reducing balance, this depreciates, so we're just gonna say A is equal to P into 1 minus I, right, to the power n. Please note that we're talking of depreciation here. So we're gonna put the amount here, this book value, and book value of 9253.7. oh sorry, made a mistake. So it's going to be, let me just use a different color. So it's going to be 92537.64 equals to this the amount of this car, which is 250,000 into 1 minus, actually let me use this side here. So we're having A is equals to P into 1 minus I to the power of n, and our A is equals to 92537.64 is equals to the price of the car, which is 250,000 rand, into 1 minus our interest rate is 22%, so it's 1 minus 0.22, right? And then we don't know n, so what we are looking for n. So just going to divide by 250, both sides 250, right? And you'll have 92537.64 over 250 0 is equals to 1 minus 0.22 to the power of n. We are looking for n, so we can use logs to solve this. So we can say n is equals to log of the base of 1 minus 0.22 and then here it's 92537.64 divided by 250,000, right? So then you punch this into your calculator, right? What are you getting? Let me know. But the answer is 4 years. 6.3. So 6.3. Just before I say anything about 6.3, I said here it's reducing balance, right? We're talking of depreciation, so it's a is equals to p into 1 minus I, right, to the power of n. And then if it's a straight line, and obviously we're talking of reducing balance, so it's going to be a is equals to p into 1 minus I multiplied by n. Please note that. Let me move now. So Mpo is granted a loan under the following conditions. The interest rate is 11.3% per annum compounded monthly. So remember, we're talking of a loan here, so chances are we're going to use a present value annuity. So we know the interest rate is 13.3% compounded monthly. The loan is a period of 6 years. The monthly repayments 1,500 rand. First payment is made 1 month after the granting of the loan, right? So 6.3.1, we are asked to calculate the value of the loan. So this is really straightforward. You just plug in your formula of 1 minus into 1 plus I to the power of minus n over I. So we're having what? We want to identify the value of the loan. We have this, we have that, we have that, we have that. So we have everything. We just want to identify PV. So let's do that. So we're having PV is equals to x into 1 minus into 1 plus I to the power of minus n divided by I, right? So we know that the investment of 1,500 rand is made 1 minus into 1 plus. The interest rate of this here is 11.3%, like 11.3% compounded monthly, right? Let's just check to confirm everything. Yes, it's 11.3% compounded monthly and for a period of 6 years, right? So we're just going to say 0.113, right? You can do that by dividing this 11.3% by 100, and then divide by 12 here to the power of minus how many years? It's 6 years multiplied by the 12 divided by 0.113 over 12. So now you can punch the entire expression here into your calculator. And what are you getting? Let me know in the comments. So this is the present value annuity, or sorry, this is the loan. Yes, the present value annuity loan of 78173.49. so this is the loan that will be taken. Done for this problem here. So I assume this is fun. It's not really as difficult as you guys thought. Kindly let me know in the comments if financial maths is easy or it's just fun. 6.3.2, how much interest will Mpo pay in total over the 5 years? So what we're going to do is we are going to identify the amount of interest that would be paid for this loan, right? We already know the loan, we already know how much is being paid here of 1.5 per month. So let's just first identify. So because we are looking at a period of 5 years, remember the previous one was 6 years, right? The loan was for a period of 6 years, but we just want to identify how much interest will be made in total for over 5 years. So what we know is the amount paid in just general sense. So please note this, it's just a general sense of the amount paid for the loan is n multiplied by x, right? So the n is the number of years, it's the number of payments, right? Remember we said the number of payments is since it's 5 years, so we're looking at 5 years multiplied by 12. The 12 comes from the compounded monthly, right? And you're supposed to get 60 here. Let me just confirm with my calculator. Yes, that's correct. So meaning that n is going to be 60. Number of payments are 60, so it's going to write 60, and we know that we are paying for 1.5, right? So the amount paid would be 90,000 rand. So this is just general sense. If we just don't consider any interest rates, whatever, this is the general amount that would be paid if you just paid that 1.5 for a period of 5 years, right? So and then the balance, or let me just write the loan that we are paying, we did calculate in the previous question, so it was 78,173.49, right? So that was the loan that was taken, and the balance. So now we're interested in the balance. What do I mean by the balance? We are going to pay for a period of 5 years, right? And we're going to pay 1.5, right? So remember that the period of the loan was for 6 years, right? But now we are looking at n is equals to 5 years, right? The difference between these two is just 1 year, which you can say it's 12 months, really, right? But it's 1 year, so you can just stretch this out. So we just want to know that amount, that extra amount, because we are interested in 5 years, and the previous question was interested in 6 years, right? I think this loan is for 6 years. So we want to know the interest that would be made. But to calculate the balance, because we just calculate the balance here of the loan, we're going to use our PV is equals to x into sorry, just didn't write properly here. So it's 1 minus into 1 plus I to the power of minus n divided by I. So yes, we're still paying 1.5, right? Okay, why am I writing 15,000? Oh, I love money. So it's 1 minus into 1 plus the interest rate of 13.3%, which is 0.113 divided by 12, right? Remember, as I said, we were looking at 6 years, but now we're looking at how many years? At 5 years, right? So the difference between these two is just 1 year. So just gonna write your 12 for monthly and multiply by 1, right? And then divided by 0.113 over 12. So why am I doing this? We want to identify the balance, the amount, the balance for this extra 1 year, right? Because we are mostly interested in only 5 years and not 6 years. If it was 6 years, we're gonna write proper number day, or proper period. So what you are going to get here is 16,945, right, 0.0. So this is going to be the balance. So remember that you're having your amount paid, which we calculated just above. So the amount paid is equals to 90,000 rand. Loan is equals to 78,173.49, and the balance is equals to 16,945.0, right? We want to identify the interest here. So for us to identify the interest, you're just going to say interest is equals to the amount paid minus into the loan minus the balance, right? So the amount paid is 90,000 rand minus into the loan of 78,173.49 minus the balance of 16945.0, and then you're just going to punch this in your calculator, the entire thing, and then you should get an interest of 28,771.51. So that is the final answer, your interest made. Done for this question. Off to the next. Okay, so going to do question 7. 7.1, we are asked to determine the f prime of x using first principles, right? And f of x is given as 2x squared minus 1. So let's do that. So we know that f of x is equal to 2x squared minus 1, right? Let me see if I wrote it nicely. Yes. So we want to find f prime of x, right? So the first thing we're going to do is going to substitute f of x plus h in this equation. So it's going to be 2 2, where there's x we put x plus h squared minus 1. So that is that, and then f prime of x is equals to the limit when h approaches 0, when h approaches 0 of f of x plus h minus f of x divided by h, right? So the limit when h approaches 0, so what is f of x plus h? It's equals to this expression here, which is 2 into x plus h squared minus 1, and then minus our f of x is given as 2x squared minus 1, right? So over h. So let's first deal with this expression here of x plus h squared, which is just this one here. So we have x plus h squared, which you can expand as x plus h, x plus h. Finding the product, it's x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. So that is that. So we're just going to substitute it there. So we're having the limit when h approaches 0 into 2 into we're just going to write that expression here of x squared plus 2x h plus h squared, and then we close the bracket, put the squared there, right? No, we don't put the squared. What am I doing? We leave it like that, and then we just say minus 1 and close this bracket here, so it's minus into 2x squared minus 1, just like that, divided by h. So what's going to happen is this 2 will multiply everything that is inside here, right? And we'll have equals to the limit when h approaches 0 into 2x squared plus 4xh plus 2h squared minus 1, close, minus into 2x squared minus 1, like that, divided by h, right? So what we'll have is the limit when h approaches 0 of 2x squared plus 4xh plus 2h squared minus 1, and then this negative will multiply everything that is inside here, so it's going to be minus 2x squared plus 1 divided by h. So the like terms, you add or subtract them, so this minus 1 will go away with this, this 2x squared will go away with this negative 1, and you will remain with the limit when h approaches 0 of, I'm just going to write this expression here, so it's going to be 4xh plus 2h squared over h, right? So we're having h as common both sides, so we're just going to factorize h, so it's going to be the limit when h approaches 0 of h into 4x plus 2h divided by h. So this h goes away with this one, they divide out, so it's limit when h approaches 0 of 4x plus 2h, right? So h approaches 0, right? So we're just going to substitute 0 where there's h. So we're going to have 4x plus 2 into 0, then the final answer would be 4x. So this is the f prime of x, right? Always check if your answer is right. You can check it beforehand or you can check it after. We know very well that our f of x is equals to is it x squared? Let me first confirm. It's 2x squared minus 1. So we know very well that our f of x equals to 2x squared minus 1, and normally when you find a derivative, it's just by dropping this 2, right? It's going to be 2 into 2x 2 minus 1, right? Minus 0, so it's just going to be 0 here. Let me just not put it even. So f prime of x, right? F prime of x, let me write it nicely. So f prime of x is just going to be, so this 2 multiplied by this 2 is 4x basically. So you must always check whether the final answer is the same as just deriving normally, right? And that way will help you see that you actually, you know what, I am correct with my steps. Thank you very much. Let's just do another question here. Now we're going to do 7.2, right? 7.2 says that we must determine the derivative of this expression here. So I'm just going to write it here. Derivative of 5 into x squared plus x cubed, right? d of dx. So we must first deal with this expression here. We know very well that when something is written like this, it basically means that x squared into 1 over 5, right? And the 1 over 5 will multiply everything here, so it's going to be x to the power of 2 over 5, right? So we're just going to write that dx into x to the power of 2 over 5 plus x cubed, like that. Then the derivative, we're just going to drop this, so it's going to be 2 over 5. Let me write this nicely. So it will be 2 over 5 x to the power of 2 over 5 minus 1 plus 3x to the power of 3 minus 1. So the answer would be 2 over 5 x to the power of so you get minus 3 over 5, right, plus 3x to the power of 2, but we don't have to write exponents in negative form, so we must always put them in positive form. So you're gonna drop this x to the power of minus 3 over 5 at the bottom, so you have 2 over 5 x to the power of 3 over 5 plus 3x squared. So you can leave it like this, or you can write it as 2 over 5 multiplied by 5 root of x to the power of 3 plus 3x squared. So yeah, it's either you leave it here or you leave it here, it's just up to you. So now let's do the last question, which is 7.2.2. We are given this expression here, and we are told that x should not be equals to minus 3 over 2, and we are asked to find the derivative of this expression here. So we have f of x being equals to 4 squared minus 9 over, oh no, let me just use another color. F of x is equals to 4x squared minus 9 over 4x plus 6. So let's factorize this top expression. So f of x is equals to 2x plus 9. We can see that it's the difference of two squares, right? And 2x minus 9, right? And then at the bottom we can factorize 2, so that we are remaining 2x plus 3, right? And I just made a mistake here. I indicated 9 when I'm supposed to write 3, because the difference of two squares So it's supposed to be 3 and 3 there, right? And yeah, thank you. So what's gonna happen is this will divide out with this, and f of x will be 2x minus 3 over 2. So we divide that 2, we have f of x being equal to 2x over 2 minus 3 over 2, which f of x is equals to x minus 3 over 2. Remember, we want to find the derivative of f of x, so f prime of x, derivative of x is just going to be 1, and the derivative of 3 over 2 is 0, right? So f prime of x is equals to 0, so that is, oh no, sorry, why am I now concluding it's 0? So f prime of x is equals to 1. Yes, so that is it for this question. Off to the next. We're gonna do question 8. I just want to let you know that doing past papers from 2018 to 2021, so if you're watching this, go and watch other past papers, because this is 2020, so go and watch other past papers to be equipped in this course. So we're having a graph of g of x being equals to ax cubed plus bx squared plus cx. A cubic function having a y-intercept of 0 is drawn below. The x coordinates of the turning points of g are minus 1 and 2. So we have everything in the graph, but sometimes the information is written and it's not presented in the graph, so always take note of that. So in this case, everything is written or is presented in the graph. So now let's just answer the question. So 8.1 says that for which values of x will g increase? So I mean, this is a point where the graph is increasing, right? This is a decreasing point and this is increasing point. So for which values of x, the only values of x we have, yes, this is 0, yes, this is minus 1, and this is 2, right? But it's still increasing here, so we don't have to start from this point. We can start from where it starts to increase and where it ends, you know. So we can simply say when x lies between minus 1 and 2, so this would be the answer for the question, because it starts to increase from minus 1 all the way up to minus 2, but it's not really equals to, because the graph is 0 gradient there at minus 1 and 0 gradient at 2. So now going to 8.2, write down the x coordinate of the point of inflection of g. So the point of inflection lies just between here. We don't know where, but we know it's between the turning points, right? Here it's x equals to minus 1, here it's x equals to 2, right? So because we are not given the equation of g, we're going to use the information that we have. This, we know that this is symmetrical, right? So we can simply say x of the point of inflection is equals to minus 1, which is this x value, plus this x value of 2 divided by 2, right? And then we're gonna get 1 over 2. So x of p is 1 over 2. That is the x value of the point of inflection. So and then 8.3 says that for which values of x will g be concave down? So concave down just looks down, right? This is concave down, you know, and this is concave up, so don't get confused. So we want to identify the values of x when this function is concave down. Concave down for this function is just this one, as you can see, it's this one here, concave down. So we are interpreting the value of x when that happens, when it becomes concave down. So remember that we said our x of p, point of inflection, is 1 over 2, right? Which lies somewhere here, I don't know where, but just let's say it's here. right? So where does the graph have concavity which is down, right? When x is greater than 1 over 2, right? When x is greater than 1 over 2, it starts to be concave down. When x is less than 1 over 2, it starts to be concave up. So when x is greater than 1 over 2 is the answer for this specific question. So let me erase here. So now 8.4 says that if g prime of x is equals to this, determine the equation of g. So remember that the equation of g is equals to, we were given, is equals to ax cubed plus bx squared plus cx, right? So it's ax cubed plus bx squared plus cx, right? And we are given that the derivative of this g here is this, right? So let's derive this g. It's equals to, we drop the 3, is going to be 3ax squared plus 2bx plus c, right? But we can see that the g prime of x is actually equals to minus 6x squared plus 6x plus 12. So what we can do is we can equate. We can say this portion here is actually equals to this. This portion here is equals to this, and this portion here is equals to this one here. So 3a is equals to 6, or let me rather say 2b is equals to 6, right? And then c is equals to 12. So this we done, this we just divide by 2 both sides, so b is equals to 3. This divide by 3, so this is negative, right, by the way. Let me write it nicely. So it's going to be equals to negative 6. So divide by 3, our a value is equals to minus 2, our b value is equals to 3, our c value is equals to 12. So we can write our equation of g, right? Because that's what we're looking for. G of x equals to ax cubed plus bx squared plus cx, which is equals to minus 2x cubed plus 3x squared plus 12x. So this is the equation that they're looking for. We are done with this question here. So 8.5, determine the equation of the tangent to g that has a maximum gradient. Write down your answer in the form of, okay, fine. So what we need to first do here is we need to identify that gradient, right? We know very well that g prime of x is equals to, okay, g of x rather, let me just first write g of x. G of x we found in the previous question, right, to be minus 2x cubed plus 3x squared plus 12x. So the g prime of that is actually this value here. So it's just going to be minus 6x squared plus 6x plus 12, right? And what we know is that because we want to identify the equation of this tangent here, right, and we know the point of inflection is between the turning points, right, which is the 1 over 2 somewhere here. So the tangent can will touch this point of inflection, by the way. So we're just going to substitute that x value of 1 over 2 into this equation to find the actual gradient of this tangent, right, plus 12, right? So once you substitute that 1 over 2 into this derivative, you get a gradient of 27 over 2. So that is the gradient of t, of the tangent. So now you have the gradient. Now you need to identify the 2 points. The first point of the tangent x of t is equals to 1 over 2. Now let's find the y value of the tangent. So we're going to substitute that y value. We're going to say g into x, which is equals to 1 over 2, is equals to what's the equation here? It's going to be minus 2 into 1 over 2 cubed, plus 6 into 1 over 2 plus 12, right? So you should get your y value of 13 over 2. So this is the y value of the tangent. So now you have the gradient, you have the y value of the tangent, everything is set. So what you will do is this. Let me just erase here. You're going to say y of t tangent is equals to mx plus c, right? Y of t is equals to the gradient, which is 27 over 2 x plus c, of which the point that we're substituting is this one, and 1 over 2. So x of t equals to 1 over 2. So where there's y, you're going to put 13 over 2 equals to 27 over 2 into 1 over 2 plus c. So you're just going to transpose this product here to the other side, and we should get, so let me remove this. We should get c being equals to minus 1 over 4, right? So that is the value of c, and y is equals to mx plus c. Y of t is equals to the gradient of 27 over 2x minus 1 over 4, right? So that is the equation of this tangent in this question. Okay, so we're going to do question 9. We are given a closed rectangular box that has to be constructed as follows. So we have a closed rectangular box. Let me just draw it for the purpose of understanding. So this is the box. It looks like this, right? And it has, let me just indicate in blue. So this is the box, right? That we are speaking about here. The dimensions of the box, the length is L, so this would be the length because the longest side. The width would be this one here, and the height would be this one here. The length of the base has to be 3 times the width, right? So the L is equals to 3 times the width. Cool. And the volume is equals to 5 cubic meters. So the material for the top and bottom parts cost 15 rand, right? So this top part here, top part is equals to 15 rand, and this bottom part here, bottom part is equals to 15 rand, and then the material on sides is equals to 6 rand. So this material here is equals to 6 rand. This material here is equals to 6 rand. Let me just write properly. 6 rand, right? Cool. So now we've represented everything in that diagram. So 9.1, show that the cost to construct the box can be calculated by cost is equals to 90w squared plus 48wh. So for us to calculate that, we can use the surface area. I mean, you should always try to figure out which equation they used. In this case, it's quite easy to identify that they used surface area, right? So the surface area of a rectangular prism, right, is given as twice the length and breadth multiplied by length multiplied by height plus, so this is just plus, right? Plus height and breadth, right? So the surface area is equal to twice. What's the length? It's actually 3. But anyways, let me just write everything on this side. So surface area is equals to 2 b multiplied by l multiplied by h plus hb, right? So which is equal to twice bl plus twice lh plus twice hb, right? And we are told, but L is equals to 3W, B is equals to W, and H is just H, right? So surface area is equals to 3W plus 2, 3W H plus 2HW, right? So it's going to be 9W squared plus 6, right? So it's going to be 6W H, just indicate properly. It's going to be H plus 2HW, right? So you can just simply, what we can do here is we can multiply with the cost, right? We are told that the top and bottom actually equals to 15 rand, right? And if you check here, this is the width, right? And the width is attached to the bottom and the top. Here it's the height and the width, right? Which is just the sides, right? Just want to show you, talking of the height and the width, it's just the sides, which are 6 rand. But when you talk of just the width is attached to the bottom part, right? So hence it's going to be 15 rand. So it's just going to be 15 rand for the 9W squared plus, and this is just going to be 6 rand for WH plus 2HW. And then what you're gonna get is you're gonna get 90W squared plus so this W, I need to correct something here. There's something wrong that I need to correct. So here it's going to be 9W squared plus 6WH, right? Plus 2HW, right? And so it's going to be the 15 rand for 9W squared, and then it's going to be plus 6 rand for the 6W. Let me just write properly, for the 6WH plus 2HW, right? So yes, and then now it makes sense. It's going to be 90W squared plus the 6 multiplied by the 6 is going to be 36WH plus 12HW, right? So these are just like terms, you can add them. So it's 90W squared plus 48WH. So if you can check, this is the cost now. So the surface area ended somewhere here, the surface area, and then when we involved the rand, then the formula became cost. So yeah, so this is the formula for the cost. So now 9.2 says that determine the width of the box such that the cost to be the box is a minimum. So whenever you talk of minimum, maximum in such word problems, this is actually optimization, right? So whenever they talk of this, you know that they want you to derive, right? So you're going to derive this cost here, but before you derive, you must just try to make everything common, because the whole point here is we want to find the width, right? And the width is a W, so this H must be removed, right? And the only way to remove it is use this volume here of 5 cubic meters, right? So it's just a matter of seeing what you have to do before you do it, right? So this is what you're going to do. We have the cost being equals to 90, so let me check. 90W squared plus 48 WH, right? WH, cool. So but what we know is that H, we need to remove it. So to remove it, volume is equals to length, breadth, height, and volume is equals to the length. We were told that it's actually equals to 3 breadth, and or the width rather, and B is equals to the width and multiplied by H. So this is going to be 5 is equals to 3W squared H, and then H is equals to 5 over 3W squared, right? So whenever we see H, we put 5 over 3W squared. Let's do that before we even solve the problem. So here we're just going to write 90W squared plus 48W into 5 over 3W squared, like that. And then we have 90W squared is equals to, so let me erase here at the bottom. So what we'll have is, let me just rewrite this. It's just going to be plus, so you will say 48 multiplied by 5 divided by 3 is going to give you 80, and this W will divide with this W squared, you remain with W over W, right? So the cost is equals to this, and to write it properly, because we want to derive here, plus 80W to the power of minus 1. So the first thing you're going to do now is derive, because we want to find W, that's the whole point. So we derive, and they told us about minimum. Derive, it's going to be equals to 2 times 90W minus 80W minus 2, which C prime of W is equals to 180W minus 80W minus 2. Because we want W, so we're going to equate this to 0. This is a concept of a turning point, by the way. So 180W minus 80W squared equals to 0, which is 180W minus 80 over W. So this is negative, by the way, equals to 0, so this is squared. And then we remove the W squared, remove by multiplying all sides, and then we have 180W to the power 3 minus 80 is equals to 0, and 180W is equals to W to the power of 3 is equals to 80. Then we divide by 180, divide by 180. W to the power 3 is equals to 80 over 180, right? And then you put the cube roots both sides, so your W is supposed to give you 0.763. So this is the width that is required in this question here. Thank you. So now we're going to do question 10. In a certain country, 10-digit cell phone numbers with the following format were introduced. So we're having a format of area code, exchange code, number, and then the number of digits we are given 3, 3, and 4. So which means the area code accepts 3 digits, the exchange code accepts 3 digits, and the number accepts 4 digits, as indicated by these examples here. So digits may be repeated. This is important. So 11.1, how many possible 10-digit telephone numbers could be formed? So we are forming 10 digits. I'm just gonna write this down. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. 10 digits for numbers. The area code accepts only 3 digits. So let's say this is the area code accepting 3 digits, and then the exchange code also accepts 3 digits exchange code, and then the other one accepts 4 digits, which is the number, right? So what we know is that the number of digits are 10, right? So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 digits in general, right? So for us to solve that, the first number of digits for this telephone number is going to be 10. Why is it 10? Because you have 10 options to choose from. You can choose 0, you can choose 1, you can choose 2, all the way up to 9 actually. I don't know why I wrote 10. So yeah, it's 10. You have 10 ways of choosing, and then the second phase, to choose for the area code, how many options do you have? You still have 10. Why? Because the digits are repeated as they indicated here, so which means it's still going to be 10 here. And choosing the exchange code, 10 ways, 10 ways, 10 ways, and then number, it's also 10, 10, 10, 10, right? So let me erase this. So now we have this situation here. So how many possible 10-digit numbers could be formed? So the possible 10-digit number to be formed, it's 10 times 10 times 10 times 10 times 10 times 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1, 2, 3, 4, 5, 6 times 10, 7 times 10, 8 times 10, 9 times 10, 10. So basically this number is just 10 to the power of 10, right? So yeah, that is how much was okay. So now we're going to go to 10.2, which says that certain restrictions were placed on the groups of digits. The area code must have 3 digits, and the first digit cannot be 0 or 1, right? So the exchange code must be 3 digits. The first and second digits cannot be 0 and 1. The number must be 4 digits. The first digit must be a 0 and 1. So the first question says that how many valid 10-digit telephone numbers could be formed by applying the given restrictions. So we are having 10, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And the first 3, it's the area code. The second 3, it's the exchange code. And then let me see if I did everything correctly. So here it's going to be like this, right? And then this would be the number, right? So to choose for the area code, let's look at the conditions. It says that yes, we want 3 digits, but the first digit cannot be a 0 or 1. So the first digit cannot be 0 or 1. Total digits are 10, but if you remove 0 and 1, minus 0 and 1, you're gonna get 8, right? So let's just write 8 for the first part. And then let's look at this second point. The exchange code must be 3 digits and the first and second digits not 0 and 1, right? So meaning it's also going to be 8, right? So what's going to happen is this: the exchange code, the first and second digits cannot be 0 or 1, right? So what this means is, okay, let me just first complete the area code. So it's going to be 10 here and 10 here, since I've satisfied this condition here. And let me just erase. So for the exchange code, the first and the last digits cannot be 0 or 1, so which means it's also going to be 8 here. So we just black, so it's going to be 8, right? And then numbers must be, so okay, if this is 8, then here, because the exchange, it says that the first and second digits cannot be 0 or 1, so this is also 8, and then here it's 10, right? And then looking at the number 4 digits, the first digit must be a 0 or 1, so there's 2 ways for this, and then the rest is just 10 10 10, right? So the answer that you're supposed to get here, because you're gonna have 8 times 10 times 10 times 8 times 8 times 10 times 2 times 10 times 10 times 10, right? So let me punch this into my calculator just to confirm the answers. So it's going to be, so the answer will be 1024 0 0 0 0 0 0, right? So this is the answer for 10.2, right? So let me erase here. So 10.2.2, determine the probability that any randomly chosen 10-digit telephone number would be a valid. So P is equals to this probability here, or rather this number here, of 1024123123 divided by 10 to the power of 10, right? So you're gonna get 0.1024. So now we're gonna do question 11, where we have Harry shoots arrows at a target board, right? He has 50% chance of hitting the bull's eye on each shot. So 11.1, calculate the probability that Harry will hit the bull's eye in the first shot and his second shot. So let's first draw this tree diagram. So we're having two things here. B will stand for bull's eye, and then N will just stand for no bull's eye. So meaning that won't be shooting or won't be hitting the bull's eye here, right? So it's gonna be B and it's gonna be N, right? So the chance of hitting the bull's eye is 50%, so it's 0.5, right? And here it's also going to be 0.5 because the branch of a tree must be equals to 1. The probability of the branch must be equals to 1. So this is the first shot. So you can say this is the first shot. You either hit the bull's eye or you don't hit the bull's eye. And then, so we just want to know the probability that Harry will hit the bull's eye in his first and second shot. So if we consider the second shot, where we have the bullseye and no bullseye, so it's still going to be a 50% chance of hitting, and we're also going to have the bullseye here and no bullseye, so 0.5, which is 50%, 0.5 here, right? And so it says, so for us to be able to calculate the probability that Harry will hit the bullseye in his first and second shot, we need to look at this situation here. So this is where he hits the bullseye in his first shot. This is where he hits the bullseye in his second shot. So the probability that he hits the bullseye in his first shot and second shot is equals to B and B, which is bullseye, bullseye, right? Because you cannot choose this one because it means now that in his second shot it missed, right? So the second shot, we're going to consider only this and this one here, which is 0.5 times 0.5. So the probability that he hit the bullseye is going to be 0.5 squared, which will give us a solution of 0.25. So 0.25 is the answer for this problem here. So 11.2, calculate the probability that Harry will hit the bullseye at least twice in the first 3 shots. So at least twice. So at least twice means twice and 3 times, or to the maximum number of shots, right? So they said in his first 3 shots, so which means we need to include another shot. So here it's going to be the bullseye and N here, so it's going to be B and N here, and here it's going to be B and N, and here it's going to be B and N. So it's going to be 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, and 0.5. So we want to find the probability that at least 2 shots to the bullseye, right? At least he has 2 he hits the bullseye. What is it saying? He hits the bullseye at least twice, right, in his first 3 shots. So where if we look at, so this is going to be the third shot. Let me just indicate third shot, right? So hitting the bullseye at least 2 times. So when they say at least 2 times, it can be 2 to the maximum. So our maximum here is 3 times, right? So it's 3 times. So it's either in this tree diagram you're going to choose 2 times or 3 times. So hitting the, let's first start with the maximum. Hitting the bullseye 3 times would be this B here, and this B here, and this B here. So that is 3 times. So which means the probability to be equals to B, B, and B, right? Plus, and then there's no other 3 times, right? So meaning that we just need to consider 2 times now, right? Because it's at least 2 times. So for hitting the bullseye twice, it can be this one here, and then the branch goes to this end, which we don't hit, but you also hit here, right? So it's going to be B multiplied by N multiplied by B, right? And then so we are done with this one here, and then another way is you will still, let me see, no, this one is out, considering this N, but you still hit twice, right? So it's going to be plus N B B, right? Or another option would be, so we are done with this one here, and we are done with this one here. and we are done with this one here. Cool. So it means now that we just need to, there's one missing though. Let me see. So if this is done, if we're done with this, and did we consider this BBN? Let me see. No. Yes. So we missed this one. So this one here, let me just use another color. Let me say, okay, this one here, okay, no, and this one here and this one here. So BBN, right? Plus BBN. So now we have the probability of at least 2 shots. So anything else is not at least 2. It's just below that, right? So then to find the value of BBB, we know B is equal to 0.5, so it's going to be 0.5 multiplied by 0.5 multiplied by 0.5, right? So for this one, and then plus for this one here would be 0.5 multiplied by 0.5 multiplied by 0.5, right? And then for this one here, so this is done, it's going to be plus 0.5 times 0.5 times 0.5, right? We're done. And then for this one here, it's plus 0.5 times 0.5 times 0.5, right? And then we are going to add all these products here, right? So it's just going to be 0.5 times 0.5. Let me write it properly. So it's 0.5 times 0.5 times 0.5 multiplied by 4, right? And the answer that you need to get for this problem here is 0.5, right? As your answer. Let's now go to another question. So another question says that in 11.3, Glenda also has a 50% chance of hitting the bullseye on each shot. Harry and Glenda will take turns to shoot an arrow, and first person to hit the bullseye will be the winner. Right? Calculate the probability that the person who shoots first will be the winner. So the probability that the person who shoots first is a winner, we're going to find it by first identifying that the probability of hitting the bullseye is this one here, plus the probability of hitting the bullseye is going to be 0.5 to the power of 3 plus the probability of hitting the bullseye is going to be to the power of 5, right? Now we're just going to find because this is a sequence of shots, right? Sequence of shots. So we're going to find the probability using the sum to infinity, right, of a over 1 minus r, right? So our a value in this case is going to be 0.5, right, divided by 1 minus our r is going to be equal to 0.5 to the power of 3 over 0.5, right? So it's 0.5 to the power 2, so it's 0.5 to the power 2, and then a probability, if you punch it in your calculator, you should get 2 over 3. So that is our answer for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.